This is the operating system basics topic, the Linux file system. The first subtopic is the file system types in Linux. There are many different kinds of file systems, varying in properties of speed, flexibility, security, size, structure, logic, and more. It is up to the administrator to decide which file system type best suits the operating system and the file it will store. Select the heading to find out more about file system types commonly found and supported by Linux. The first is X2, second extended file system. X2 was the default file system in several major Linux distributions until supplanted by X3. Almost fully compatible with X2, X3 also supports journaling below. X2 is still the file system of choice to flash-based storage media because its lack of a journal increases performance and minimizes the number of writes. And because flash memory devices have a limited number of write operations, minimizing write operation increases the device lifetime. However, contemporary Linux kernel also supports X4, an even more modern file system with better performance and which can also operate in a journal-less mode. In the X3 extended file system, X3 is a journal-less file system designed to improve the existing X2 file system. A journal, the main feature added to X3, is a technique used to minimize the risk of the file system corruption in the event of sudden power loss. And the file system keeps a log, a journal, of all file system changes about to be made. If the computer crashes before the charger is complete, the journal can be used to restore or correct any eventual issues created by the crash. And the maximum file size in X3 file system is 32 terabytes. In the X4 extended file system, designed as a successor of X3, X4 was created based on a series of extensions to X3. While the extension improved the performance of X3 and increased support to file size, Linux kernel developers were concerned about stability issues and were opposed to adding the extension to the stable X3. The X3 project was split in two, one kept by X3 and its normal development and the older named X4 incorporated the mentioned extension. NFS Network File System. NFS is a network-based file system, allowing file access over the network file system. From the user standpoint, there is no difference between accessing a file stored locally or another computer on the network. NFS is an open standard which allows anyone to implement it. And CDFS Compact Disk File System. CDFS was created specifically for optical disk media and swap file system. The okay, swap, swap. The swap file system is used by Linux when it runs out of RAM. Technically, it is a swap partition that does not have a specific file system, but this is relevant to the file system distribution. When this happens, the kernel moves inactive RAM content to the swap partition on the disk. While swap partition, also known as swap space, can be useful to Linux computers with a limited amount of memory, they should not be considered as a primary solution. Swap partition is stored on this switch, which has much lower access speed than RAM. And HFS plus of HFS plus, hierarchical file system plus, a file system used by Apple in its Macintosh computers. The Linux kernel includes a module for mounting HFS Plus for read-write operations. APFS Apple File System, an update file system that is used by Apple devices. It provides strong encrypting and is optimized for flash and solid-state drives. Drives and master boots record MBR located in the first sector of a partitioned computer. The MBR stores all the information about the way in which the file system is organized. The MBR quickly hands over control to a loading function which loads the OS, the operating system. Okay. Mounting is a term used for the process of assigning a directory to a partition. After a successful mount operation, the file system contained on the partition is accessible through the specific directory. In this context, the directory is called the mounting point for that file system. Windows users might be familiar with the simple concept, the driver letter. The command output shows the output of the mount command issued in the Cisco CyberOps VM. Okay. Mount. Okay, proc type pro. Okay. Okay. When issued with no options, mount returns the list of file systems currently mounted in a Linux computer. While many of the file systems show are out of the scope of this course, notice the root file system highlighted. The root file system is represented by the slash symbol and holds all files in the computer by default. It is also shown in the output that the root file system was formatted as X4 and occupies the first partition of the first drive, and def is the one. Okay, the next topic, Linux roles and file permissions. In Linux, most system entities are treated as files in order to organize the system and enforce boundaries within the computer. Linux uses file permissions. File permissions are built into the file system structure and provide a mechanism to define permissions on every file. Every file in Linux carries its file permissions, which define the actions that the owner, the group, and other can perform with the file. The possible permission ranks are read, write, and execute, and the ls command write the L parameter lists additional information about the file. Consider the output of the ls-l command in the command output. Okay, list L space .txt. The output provides a lot of information about the file space.txt. The first field on the output displays the permissions that are associated with the space.txt. Okay. File permissions are always displayed in the user group and order order. The file space.txt has the following permissions. The dash means that this is a file for directories. The first dash will be a D. The first set of characteristics is for user permission, R, W, X, the user analyst who owns the file can read, write, and execute in the file. Okay, read, write, and executing. Okay, the user analyst. Okay, the second set of characters is for group permissions. RW. Okay, the group staff who owns the file can read and write to the file. The third set of characters is for any other user of group permissions. Okay. Any other user or group on the computer can only read the file. Okay. The first is this part analyst who owns the file and can read, write, and execute. This part is the second set of characters for group permissions. The group staff who owns the file can read and write to the file. And the third set of characters for any other user of group permissions only read. Any other user of group on the computer can only read the file. The second field defines the number of hard links to the file, the number one after the permissions. A hard link creates another file with a different name linked to the same place in the file system, called an inode. Okay, this is the second field. This is in contrast to a symbolic link which is discussed on the next page. Okay. The third and fourth field display the user analyst and group staff who owned the file respectively. Analyst and staff. Okay. And the fifth field display the file size in bytes. The space.txt file has 253 bytes. Okay, this is field. And the sixth field displays the date and time of the last modification. May 2012 49. And the seventh field displays the file name. Okay, it's here. Okay, the figure shows a breakdown of the permission in Linux. Okay. Use octal values to define permissions. Binary octal permission description: access, execute only, write only, write and execute, read only, read and execute, read and write, read, write, and execute. In format binary and format octa in permissions. Use octal values to define permissions. And file permissions are a fundamental part of Linux and cannot be broken. A user has only the rights to a file that the file permissions allow. The only users that can override file permission on a Linux computer is the root user. Because the root user has the power to override file permissions, the root user can write to any file. Because everything is treated as a file, the root user has full control over a Linux computer. Root access is often required before performing maintenance and an administrative task. Because of the power of the root user, root credentials should use a strong password and not be shared with anyone other than system administrator and other high-level users. Okay, the next topic is hard links and symbolic links. A hard link is another file that points to the same location as the original file. Use the command ln to create a hard link. The first argument is the existing file and the second argument is the new file. Okay, the first argument is the existing file and the second argument is the new file. As shown in the common output, the file space.txt is linked to the space.heart.txt, and the link field now shows to ln space.txt space.heart.txt. Okay, there with the command ln. Okay, and so ln space.txt space hard.txt. Okay, this is below now the above part. Space hard txt. Okay, show testing hard links. Space. Okay. There are the voyage of the Starship Enterprise, its continuous mission to explore strange new worlds. Okay. Both files point to the same location in the file system. If you change one file, the other is changed. As well, the echo command is used to add some text to space.txt. Notice that the file size for both space.txt and space.hard.txt increased to 277 bytes. If you delete the space.hard.txt with the rm command remove, the space.txt file still exists. As very filled with the more space.txt command. A symbolic link, also called a symbolic or short link or soft link, is similar to a hard link in that applying change to the symbolic link will also change the original file. As shown in the command output below, use the ln command option as to create a symbolic link. Okay, echo hello world in test.txt. ln s text.txt my text.txt. Echo it is a lovely day me text.txt more test.txt. Okay, hello. Remove text.txt more my text.txt more stat of my test.txt file there's no such file or directory and my test. Okay, analyze. Okay, notice that adding a line of text, the test.txt also adds the line of my test.txt. However, unlike a hard link, deleting the original text.txt file means that my text.txt is now linked to a file that no longer exists. As shown with the more my test.txt and lsr my text command. Although symbolic links have a single point of failure, the underlying file. Symbolic links have several benefits over hard links. Okay, one moment. This is very important. Symbolic link links have several benefits over hard links. Okay. So locating hard links is more difficult. Symbolic links show the location of the original file in the lsl command, as shown in the last line of output in the previous command output. My test and test. Hard links are limited to the file system in which they are created. Symbolic links can link to a file in another file system. Okay, repeat, hard links are limited to the file system in which they are created. Symbolic links can link to a file in another file system, and hard links cannot link to a directory because the system itself uses hard links to define the hierarchy of the directory structure. However, symbolic links can link to directories. Okay, this is the lab for the next video. See you in the lab.